Okay, based on the this statement right here, isosceles triangle, we're going to make the assumption that the isosceles triangle in question is triangle A, B, C, which allows you to conclude that the base angles are congruent. And since the vertex angle is 20 degrees, that leaves 160 degrees for the sum of the base angles. Each has to be 80. That allows us to fill in all these angle measures that you see here, 20 here, 30 here. Then by the fact that the sum of the angles of a triangle is 180 and vertical angles are congruent, we can fill in all these angles. I admit when I first saw this problem, I thought, oh, we're just going to fill in the missing angle measures and we'll be able to figure out what epsilon is. But when you reach this point, it's not so clear how to figure out what epsilon is. So here's what I came up with. I'm sure there must be an easier way to do it, but in triangle DAE, that's this triangle right here, the sine of epsilon is to its opposite. I'm sorry, the sine of epsilon is to its opposite side, which is D, as the sine of 20 is to its opposite side, which I'm representing with the letter A. And by the way, if I share my screen and go to Desmos, here's a picture of that triangle. D is the length of it, representing the length of the base, and this theta sub 1 is actually angle epsilon that we're trying to find. Notice that it doesn't matter what the measure of D, the base is, that angle is always 30 degrees. So apparently the measure of E doesn't depend on the base. Okay, so if this is D and this is 50 and 50, then triangle DAB is also isosceles. So AD is also equal to the length of this leg. So that's why I've got DD here. Okay, so there's what epsilon is. Inverse sine of D sine of 20 all over A. Now we're going to let B equal the length of AE. And what I'm trying to do is come up with an expression for A in terms of D. So using the law of cosines, D and B are the legs that don't include side A. So A squared equals D squared plus B squared minus 2dB cosine of the included angle 20 degrees. Now, if I could find an expression for the length of B in terms of D, I would have, I could get rid of the A in this expression right here. So using this green triangle, I can say that B, this side right here, is to the sine of 80, its opposite angle, as D is to the sine of 40. So B equals D sine of 80 over the sine of 40. And so now I'm going to replace B in this equation right here with this D sine 80 over sine of 40. Notice that every term down here has a D squared in it. So I can factor out the D and then take the square root of the D. So there's an expression for the measure of A. And I'm going to substitute that right here. And here's what happens. There's formula for epsilon. Here's the formula for A that we uncovered. If I put this expression in for A, the D's cancel out, and lo and behold, epsilon does not depend on the length of the base. It's the inverse sine of this mess right here, which is 30. And that is the measure of epsilon. Notice that if I include this whole thing in the square root here, that this expression inside is 0.25 or 1/4. Square root of 1/4 is 1/2, and the angle that has a sine of 1/2 is 30 degrees. Okay, it's probably possible to use some trigonometric identities to reduce this expression to 1/4 without having to use a calculator to do this calculation right here. But that gives you the idea. There you go. Hope that helps. If you have any questions, post a comment.